My name is Dr. Andres.
Wait, you're too fast.
Now, hello everyone. My name is Dr. Andres Plazas Malagon. I'm an astrophysicist at Princeton University, and it's my pleasure to welcome you all to the special edition of Astronomy on Tap in St. Louis. Astronomy on Tap is a series of free public astronomy-related presentations in a bar that aim to bring astronomy to people in a more relaxed and informal setting, in which we hope the audience can also learn about the speakers themselves. Due to the current global pandemic, we have been continuing our event online. Astronomy on Tap St. Louis is presented in partnership with the Academy of Science St. Louis, the Department of Physics of Washington University in St. Louis, the McDonald Center for the Space Sciences, the JPL's Solar System Ambassadors Program, and Urban Chestnut Brewing Company. Our special guest from tonight will be introduced by my colleague and co-host, Dr. Alexander Haber from Washington University in St. Louis. Alex?
Thank you, Andres. Yeah, it's a special honor to introduce somebody who, among St. Louis-based science and space enthusiasts, probably doesn't even need an introduction. But since we also have quite some international audience on YouTube, I will give it my best shot anyway. So our guest today is NASA astronaut, Colonel Dr. Robert Behnken. Dr. Bob Behnken was born on July 28th in St. Anne, which is a suburb of St. Louis in North St. Louis County. I was told by many natives here that I have to mention that he graduated from Pattonville High School in Maryland Heights in 1988. As a postdoc of Washington University in St. Louis myself, I proudly mention that Dr. Behnken received his Bachelor of Science degree in physics and a Bachelor of Science degree in mechanical engineering from WashU in 1992, before he continued his academic career at Caltech, the California Institute of Technology in Pasadena. There he obtained a master's degree in 1993 and secondly a PhD degree in 1997 with a thesis on the control of instabilities within compressor systems. After graduate school, he entered the Air Force, where he attended the Air Force Test Pilot School. He accumulated more than 2,000 flight hours in more than 25 different types of aircraft during his Air Force career. In July 2000, Dr. Behnken was then selected by NASA as an astronaut candidate. As one of his first assignments after training, he actually spent 7 days underwater as an astronaut during the Nemo 11 mission. Since then, he has been to space 3 times on 2 space shuttle missions to the ISS. With STS-123 in March 2008 and STS-130 in February 2010, he delivered various modules to the ISS and performed a total of 6 spacewalks. Back on Earth, he served as NASA's chief astronaut from 2012 to 2015 before being selected to NASA's Commercial Crew Program. In August 2018, then he was assigned to the first cruise test flight of the SpaceX Crew Dragon, which successfully launched on May 30 of last year. Together with his fellow astronaut, Doug Hurley, he joined the ISS crew for 2 months on the space station before returning safely back to Earth on August 2nd. So without further ado, Bob, welcome to Astronomy on Tap St. Louis.
Well, thank you, Alex, and thank you, Andreas. I appreciate the complete introduction, kind of covering my career with the shuttle flights, as well as the SpaceX Dragon launch that happened last summer. I do have a short video to share with folks that kind of covers that mission. So if we could jump right into that, that would be great.
Absolutely. Alex?
Welcome aboard. Dragon, SpaceX, ComCheck, ground stations.
SpaceX Dragon, we're go for launch. Let's light this candle.
3, 2, 1. Ignition. Liftoff of the Falcon 9 and Crew Dragon. Go NASA, go SpaceX, Godspeed, Spot and Dog.
On behalf of the entire launch team, thanks for flying with Falcon 9 today. We hope you enjoyed the ride and wish you a great mission.
We would like to welcome you aboard Capsule Endeavour. We do have a friend on board with us, Trimmer, the Apatosaurus. I think I was requested to do a backflip. Good night, Megan and Theo. And Karen and Jack.
MD Houston flight. Houston is go for undocking and departure.
Dragon is committed to undock.
SpaceX Dragon on Dragon to ground. We are ready for the systems brief.
Copy. As stated, Dragon's in a healthy state. We are proceeding toward the primary landing site, and your timeline is current. Visual, 2 drones out.
300 meters. We are braced for splashdown.
Copy, brace for splashdown. Endeavour, on behalf of the SpaceX and NASA teams, welcome back to planet Earth, and thanks for flying SpaceX.
It's a humbling experience to be a part of what was accomplished.
It's great to see how excited everybody was. We hope it brings a little bit of brightness to a pretty tough 2020.
Well, thank you. I'm glad we're able to share that video. The SpaceX team did a wonderful job of preparing us for flight and getting that vehicle ready, and then getting us to the space station, where we were able to help Chris Cassidy, the only US OS crew member, that's the partnership, except for our Russian colleagues, that operates the one half of the International Space Station, and help that crew out for a couple of months, accomplishing some science and some much needed maintenance during some spacewalks while we were up there. And so with that, I hope you enjoyed what you saw tonight, and were able to follow the mission a little bit last summer. And I'm ready to take questions, Alex and Andreas.
Thank you so much, Bob. So we're going to start with a few questions from St. Louis, as we know that you're from the area. So I thought I would start by asking them maybe at the same time. People are interested, for example, can you see the Gateway Arch from space? Or what is your favorite St. Louis food? And can you get toasted ravioli on the ISS? Or are you a fan of St. Louis sports team? Or what about the Cardinals?
That's a lot of questions kind of rolled up together. I think I did take a picture of the St. Louis area from the International Space Station, and I wasn't able to capture the arch. I was able to capture the rivers kind of separating Illinois from the Missouri side, and break that out very clearly. I think you can pinpoint the location where the arch is, but really having it be discernible as an arch, I wasn't able to capture that. Maybe another crew member with a little bit more time and a stronger camera lens would have been able to. I just wasn't able to. And you really need the atmospherics to cooperate, just like you do from an astronomy perspective. You know, you find that perfect time where the lighting conditions are wonderful, but then there's cloud cover and you just can't get a shot. And so I was able to get one, but there is some cloud cover, and there was no St. Louis Arch visible. Let's see, in terms of things that I liked about my time in St. Louis, I was a big St. Louis Cardinals fan when I spent time in St. Louis. I grew up listening to them on the radio. But having moved to Houston, you know, after 20 years, the Astros have been a good team as well. And so it's always exciting for me to see the Cardinals and the Astros play. But I will say that having been in Houston this long, I've kind of transitioned a little bit to the Astros. You know, being an astronaut, I think it might be required to root for the Astros, I guess. As far as food goes, I did work a restaurant series of shifts. I had a job as a busboy with an Italian restaurant that served toasted ravioli, and that was, we could get a free meal each night if you worked a shift. And I always got toasted ravioli at that restaurant back in Houston when I was in high school. Maybe I've covered them all. There, you probably had another one that I missed there, but that's my St. Louis summary.
No, that was perfect. And there is actually one more question from Rika from St. Louis, and they ask, How has your upbringing in St. Louis affected your career as an astronaut today?
You know, the thing for me about growing up in St. Louis, it's a little bit about the city, but it really was about the kind of the mindset that I think my parents instilled with me. And so my dad was a construction worker and my mother worked at McDonnell Douglas, which is now Boeing there in St. Louis. So I kind of had a construction worker, aerospace background as a kid, and spending the summers, you know, working as a laborer on construction sites, hauling concrete bags or kind of doing menial tasks really focused me on wanting to get a college education. I think that was probably the thing that my dad instilled in me the most was, you know, the life is hard, you know, because I would see older people trying to do that job that I struggled with, you know, as a strapping 18-year-old. And I really recognized that manual labor was important, but I wanted to do something else. And I think that's what motivated me, honestly, to go off and study in school. Now, by the time I got to my current job as an astronaut, all that time as a laborer kind of came back to me when it was time to go out the door and do spacewalks, because those activities can be very strenuous, very physical in nature, and you really do need to understand how to put things together and take them apart in order to execute a spacewalk. And, you know, I'm proud that my dad gave me that experience as a kid.
Absolutely. Thank you very much, Bob. Alex?
Yes, and normally in Astronomy on Tap, our guests talk a lot about their research. So we were wondering, can you in a few sentences explain what your PhD thesis was about?
Sure, absolutely, Alex. My PhD thesis was a program that was funded by the Air Force. The Air Force really wanted to understand how, for jet engines, as you kind of push the performance more and more, the way you do that is by really getting kind of perfect control over the air that's coming into the engine, and then managing that in a very specific way as it moves through the stators and rotors inside the compressor and eventually to the turbine, and the combustion goes on. All those things that happen in a jet engine, they really depend on what happens at the very front end and how well you can control, you know, what's going into the engine. And so whether that's birds or air disturbance, all those things are bad for a jet engine. They in various senses impact, you know, the physics that's supposed to be from the, you know, you get reality instead of what you hoped it would be if you don't have full control of that. And so that's what my research was. It was trying to manage and control that airflow coming into the engine so that we could get the best performance. Or if we didn't get, you know, the kind of airflow that we wanted, we at least didn't create what were called combustion instabilities or surge or rotating stall, some bad things that can happen in the engine that create some significant loading events and cause the effective backfiring of the engine. You can get flames coming out of the front and side at the back if you don't manage that correctly. And so that was what my research was. We put a series of sensors and we put some actuators to kind of move air around to try to prevent those disturbances when they came in from turning into something bad for the engines. That wasn't two sentences, but that's how I describe it.
So that sounds very hands-on and experimental, or did you also perform simulations already or computational aspects to the thesis as well?
That's a great question, Alex. At Caltech, the group that I was in kind of tried to bridge the gap between experiments and theory. And so we actually had a compressor rig that was put together by one of the undergraduates at Caltech. And then the actuators that got added to it were ones that I had used from a project at Washington University a few years earlier. We had a vehicle that ran on natural gas. I was able to get the injectors from that natural gas vehicle and use them to inject air into the front of this compressor from a controls perspective. And so then after getting that to all work, we had to come up with a model that would kind of be predictive, that would have similar characteristics as we put disturbances in the front. Would we get the same sorts of reactions out of the compressor? And then once we got that working, we had to figure out a simplified model that we could apply a control strategy to. And so it really was a very complex model to kind of really get the physics down so that we were predicting what the behavior was going to look like, and then putting together a simplified model that you could control, and then, you know, demonstrating it with the hardware. So we did all those things. I did all those things as a part of my project, but that was 20 years ago. So
very interesting. And you still remember all of it.
I remember that much of it.
You already mentioned the Air Force, and we actually have a question from Phil in St. Louis who asked, so during your time at the Air Force, did you see any unidentified aerial phenomena while in orbit or while flying?
No, that's a great question. I've been asked that question in Japan on my post-flight after my first mission, STS-123. It was a popular question back then, and it continues to be today. I think the answer is we've all seen unexplained things when we are looking out the window. You know, we are trained as astronauts, if we see something that's unexplained, to get a camera as quick as possible and try to capture it in some way, whether that's video or still photos, so the ground can analyze it. In some cases, the photos that we might capture are getting a piece of ice or a piece of fabric that has come out of the shuttle payload bay, for example. That was pretty common in the shuttle days, that a piece of debris that got left behind in the processing. Not that they had a lot of debris, but it's a big vehicle, and it doesn't take much to have one or two things left behind over the years that processing can take in some cases. But we get a camera and we would try to capture it. So I think, have I seen unidentified flying objects? I absolutely have. And our job was to do our best to identify them, to make sure our ship was still in good shape as we continued the rest of the mission. I did have some time while I was on board the International Space Station to set up some cameras. And I'll tell you that some of the unidentified flying objects that we find in the photos are ones that we don't find until post-processing and collection of those images, or bringing them together and trying to make a movie potentially out of a series of still photos, or kind of pushing the processing to really search for them. And sometimes it turns out that, you know, I was able to capture the comet Neowise with some processing and some sequential photos out of the cupola, the underside of the International Space Station. I captured satellites that I wasn't anticipating, but they were there nonetheless. I think I captured what might have been a meteor at one point, kind of coming through the atmosphere. Just a lot of things like that that are not identifiable, at least initially. We've everything that we've dug in hard on, we were able to understand, at least from the ones that I know about.
Great. So we, of course, have a lot of questions about your astronaut training that Andres will read to you now.
Yes, we have, for example, one question from Valeria in Colombia and one from Lex in Canada. So it's two questions. So the first one is, what is the most valuable skill that you learned during your astronaut training? And then bringing it to the present, how is the training of astronauts nowadays in terms of new technologies, for example, or VR or simulators?
So those are some great questions. I think the most valuable thing that we learn as astronauts is kind of how to learn. We go through a lot of training on a lot of different systems, whether it's spacewalking or conducting science activities or flying spaceships or operating a robotic system. We get pretty good at, from a simple set of instructions, learning how to operate kind of complex systems in the face of that. So that's what it takes if you want people to kind of be able to jump in and do DNA sequencing on board the International Space Station. You need a machine that is simplified from an operations perspective, but at the same time, sample prep or otherwise, you need people who are able to pick up the procedures that they're presented with and kind of execute some very complex technical tasks with minimal training or minimal exposure. We don't have, you know, our entire careers to dedicate to DNA sequencing or to some of the other activities, photography, spacewalks, all those things. We aren't able to do that and without having been trained generically on a lot of different things, and then, you know, honing that skill of kind of jumping in and doing a technical task with kind of little training by understanding what's important and having that communicated. And we don't do that by ourselves. The teams that put it together know how to communicate that information to us as well. So it's a team to get us there. As far as the training itself, we use all of the techniques that you might think that are out there that you've heard anything about. We do VR sessions. We have a really neat facility here at the Johnson Space Center that isn't much to look at when you actually sit in it, but we'll have a VR headset on. It will be displaying a kind of a cartoonish version of the International Space Station. But the thing that's really cool about it is it has some force reflection capability. And so you can be in there, and in addition to being able to see what it would look like where you are on the space station, you're able to grab one end of a large piece of structure and have another person grab the other end. And as you move it around, they feel what the other end of that thing that you're moving would feel like if it was floating in zero gravity and somebody was pushing on it on the other end or at a very different location. And so I know that might be a hard thing to kind of get your mind around, but there is the VR experience, both in being able to see it visually, part of the VR, but there's the physical part of being able to reach out and touch something and have the right force reflection, the right feel to that system be reflected and to be representative as well. And we got a lot of great training when we were assembling the space station for doing those sorts of simulated tasks on the ground before we did them in space.
Yeah, those hands-on experiences are absolutely crucial for this. Absolutely. And in terms of that, Rosario from Mexico asks us, what would you recommend to young people who want to become an astronaut?
For Rosario, that's a great question that we get a lot as to what do we recommend for folks who want to become an astronaut. The first thing I would suggest is that, you know, there are a lot of science and engineering types and flavors that are out there. And so what you need to do is find one that is truly something that you like to do, that, you know, hopefully that you love it, but one of those that suits you well and that you really enjoy doing, because those are the things that you'll do your best at. And it's going to be important. I think what you don't want to do is pick one that you don't like, but think that you need to do it to become an astronaut, because you know what, you might get the job and then have to do that thing that you didn't really like once you got to be an astronaut. And so finding that little niche inside of engineering or science or medicine that is something that you're truly passionate about, and focusing on that is going to mean that if you get the job, it'll be something that you love to do, and you'll do your best at it because it is something that you truly enjoy.
And that's actually an advice that we get a lot when we're in academia. Try to find that niche where you're going to be good at, right? Because you're going to be doing this for a long time. And you just mentioned the International Space Stations and the type of experiments that are conducted there. So Alex has some questions related to that, very interesting questions. Alex?
Okay. Yes, I might need to give a little bit of background to the audience. So many scientific instruments are mounted directly to the ISS, right? Instead of becoming an independent satellite, which has a lot of advantages, like we can get help from astronauts and they get brought up there. And what I think people don't realize is that often it takes up to a decade or longer from the first idea until this thing is then built and sent up, and how much hard work goes into an experiment before it goes to the ISS from us scientists. And I remember then, for instance, NICER, that is a neutron-star interior composition explorer, that's an experiment on the ISS right now. And I talked to the leading scientist back then, and I asked her, what happens if the SpaceX rocket explodes? What is the plan B? And she said, there is really no plan B. So our question is, like, do you interact with the scientists who build these missions, who plan these instruments before they get brought up there? Do you see the other side as well?
You know, it really runs the spectrum, Alex, the experiments that we interact with. We have some that we're able to reach all the way back and interact with the PI, the principal investigator who's put the science together. In some cases, we may even be able to talk to that person from the International Space Station as we try to get their experiment up and running and get the hardware kind of operating for the first time. In other cases, you know, we may never interact with the individuals who put the hardware together, but we operate the payload for them once it gets to the International Space Station. And we have other payloads that go to the space station that get operated entirely from the ground. The crew may install them, or they may interact with them if they need a repair. But if they operate as designed, they may not get any interaction by the crew, even with the payload. It may just do its science on its own and report back autonomously. The space station really just provides the platform to safely get it to low Earth orbit and operate it and potentially bring it back. So it really runs the spectrum of activities. For me, I had a couple of activities that I was setting up hardware and I was able to interact with the team that had put together that hardware and have discussions with them. But the other payloads, I really primarily just operated from instructions, and the scientists would get the data and then decide what processes or samples were going to be collected next, potentially, but to not coach us on each of the individual sample operations.
Thanks. I think Andres has another question.
Yes, we have a question related to your time, or soon of your time after you were the chief of the astronaut office. So you took this position soon after the last shuttle flight, and our audience is asking, how did you and the rest of the NASA astronauts handle transitioning to relying on the Russian Federation for access to space? Did you expect at that time that it would take so long to regain that capability?
You know, I appreciate that question. It's something that we thought a lot about when I was serving as NASA's chief astronaut. I took a role as a deputy for the chief that preceded me. You know, we were still operating the space shuttle right up until the time that I started filling a leadership position. I did my mission, STS-130. We flew 3 more shuttle flights, and then we were kind of wrapped up with the shuttle program. When I served in those leadership positions and as the chief of the astronaut office, I tried to accomplish 2 things. We already had cargo vehicles that were being built by Orbital. There was one in work by the Sierra Nevada Corporation that I think it's going to come around for a future round and is under contract to eventually get the space station here relatively soon. And the Dragon capsule, I worked on the HTV, which is the transfer vehicle, the H2 transfer vehicle from Japan, and get that to the space station for the first time. All of those cargo vehicles that had to come to space station, there were experiences about how you bring a ship to the space station that I wanted as the chief to make sure I had lots of astronauts who knew how to do that for when the time came to bring the first new crewed vehicles to the International Space Station. And so that was one facet of what I did, is I put astronauts in positions where they would get experiences with all those visiting vehicles, so that the time came to bring crews aboard, they would know exactly how to do that, or would have had some experiences to set them up for success. The next thing I did was spend a lot of time taking as many people as I could to Star City and then on to Kazakhstan to experience the Soyuz launch process. When we finally launched the commercial crew vehicles, we had astronauts who had not been in the program at the time of the last shuttle, but they had seen Soyuz launches and landings, and that was their new experience. And so I had tried to get as many people that experience as I could, so that when the time came to really fly these new vehicles, I had plenty of people who knew what it was like to bring new ships to the space station and knew what it was like to make that pilgrimage all the way to Kazakhstan to launch. And I think now those folks all truly appreciate how nice and convenient and helpful it is to be able to launch from Florida. And that experience is a very, they just really appreciate it after having gone down the path of interacting with our cosmonaut friends and flying on the Soyuz or launching via the Soyuz.
Yes, and I think that a lot of people in the United States, of course, are very excited and proud that you have managed to do it again from American soil. And we have a few questions about that in a few minutes. But before that, we wanted to ask you a somewhat personal question. That is, you already had finished the astronaut training when the Columbia disaster happened in 2003. How did that affect your personality, you personally? Did you consider maybe dropping out of NASA at this point, or how can one put the existing risks to the back of their mind and fully focus on the task at hand? And finally, you as an astronaut, do you have any mental tips that maybe all of us can apply in real life?
I think I'll start with the first question about the Columbia experience. And I'm a military officer as well as an astronaut. I had gone through the Air Force's test pilot school, and I think I had an appreciation that flying on space shuttles was dangerous. As a kid, I was in high school when we lost Challenger and watched that kind of happen real time on television, and then watched the hearings that kind of uncovered the details of the O-rings and the cold weather and how that was all interconnected and the decision process. I kind of watched that transfixed as a high schooler. And so I think I had a pretty good appreciation of the danger associated with flying in space. And as a military officer and a tester from out at Edwards Air Force Base, we try to manage risk, but we recognize that there was danger involved in what we did. As an astronaut, I was in Florida the day that Columbia was scheduled to come home, and was scheduled with Doug Hurley, the person who flew with me on the SpaceX mission. Doug was the lead, and I was supposed to go in with him. I had done the previous shuttle flight, and so I was the experienced person and going to help him as he was the lead for pulling the Columbia crew out of the vehicle after they landed, and then operate Columbia there on the runway until they were able to get it back into the hangar. And it didn't come back. And so our roles rapidly shifted to taking care of the families and the group of folks who were there to catch the vehicle that didn't come home. And then we ended up going through the entire excruciating process of collecting all the debris and understanding what went wrong so that we could go forward. And I think there may have been astronauts. I didn't talk to any that felt this way, but there may have been folks who didn't share it. But for me, it was a kind of a reliving of, hey, that goal of that Challenger commission that was put together to understand what had happened, figure out what went wrong, and figure out what we needed to do to fix it to continue to fly. And so I was really focused on that job. I moved almost to East Texas here, collecting debris, getting it to Kennedy Space Center. I actually drove the recorder. There was a magnetic recorder on board Columbia that was collecting the instrumentation data. And Columbia was the oldest orbiter, I think, that we were still flying at the time. And it had all of the test data, and test speak, we'd call it the orange wire, to collect the heating all over the wing the left wing that actually had the debris strike and had the hole. And so there was a ton of information. I was with the team after they brought that recorder in, and I drove it from East Texas back to Johnson Space Center. We had to bring an extra person because it was so important that they wanted two people to be with it at all times, so it didn't get lost in transit. But brought it home, and we collected that data off there and figured out what went wrong. And then I flew the first mission that we did a night launch on the space shuttle after we had recovered and we're flying again and we're ready to go again at night, and kind of lived through that entire process, all the engineering that had to go into it, all the data collection, what we needed to do in order to, while we were flying, get good photos and collect good information to make sure no more foam had come off of that external tank or created something that we needed to worry about while we were in flight. I did the training for the rescue mission, STS-400, for the Hubble flight. Hubble was a little bit different. It couldn't loiter at space station for 3 or 4 months while you got another orbiter ready to go get that crew. We had to have another space shuttle on the launch pad. So I'll say that what we did was figure out what needed to be done to continue to fly safely, or from a human lives perspective. If we needed to lose an orbiter, we would be ready for that potentially, but we wanted to have a plan to save the crew. We would lose the mission, but save the crew was the mindset that we went in. We figured out a lot of ways in order to make that safer, or make us ready in case we needed to do any of those things. And so I didn't have second guessings. I really, went back to Richard Feynman squeezing a piece of O-ring material and saying, "Hey, what's this?" And taking that cap to the work that needed to be done, and just put your hat on and get to work. I think what was the second question that you had? That was a long answer, but the second question
is, do you have any mental tips that maybe all of us can apply in real life from an astronaut? What?
From an astronaut perspective, for all of us, we have a thing that one of our astronauts from a few years ago kind of described as 2 seconds of remorse. And so when you're doing an activity and the world is watching in some sense, and in many of the cases, whether that's on a spacewalk or because you're launching on a brand new vehicle, the crew can make a mistake, and that can be something we really don't want to do. But we don't have the luxury of feeling bad about it or having remorse about it kind of in the moment, because nothing's more important than the next thing you're going to do when you're actually in space. And so for each of us, it's putting those, because we all make mistakes. We all have things that we wish we had done better at, but it's recognizing that you made a mistake, doing the next best thing after that mistake, and moving on from it so that you can continue to work towards a good outcome. And so from an astronaut perspective, I think it's that 2 seconds of remorse, and then, you know, nothing's more important than the thing you're doing right now, not that thing you did 2 seconds ago.
Yes, absolutely. That's great advice. And you mentioned the families of the astronauts, and Alex has a couple of questions related to your family. So, Alex?
So what we might need to add that your wife, Dr. Megan MacArthur, she's an astronaut herself, and she's on the ISS right now. And you already talked a little bit about the risks and how of the rescue mission. And if I'm correct, if I'm informed correctly, she was the last person to interact with the Hubble Space Telescope. So we are really grateful for that, for all the nice pictures we got. And you were assigned to the rescue mission that would have flown if there went something wrong with her mission. So how do you prepare for such a mission? Is it really full on, you pretend that you will fly like a normal flight? And was there some extra mental pressure for you considering that your wife was on the primary flight?
You know, that's a great question, Alex. And it's one that I think that NASA leadership thought a lot about when the time came for me to, you know, be a part of the STS 400 mission. And in the end, the way it played out was the schedule slipped, and another crew also trained to be the STS 400 crew when there was a data interleaver or another piece of processing equipment that they needed to ready a spare for that caused the Hubble mission to be delayed, I think, close to 8 months, and that created another opportunity. But at the time, it was about 3 weeks prior to launch, and I got that close, I think, to, you know, being the backup crew for her flight. We considered a lot as to, you know, what the best way to prepare for that mission was. And we knew which space shuttle, and each of the space shuttles was a little bit different. They weren't all identical. The displays in some cases were older or a different model or displayed different information. The panels even inside the vehicles are slightly differently configured from vehicle to vehicle. The hardware for navigation was different from vehicle to vehicle. And so what prepared me to be the right person for that flight was that my crew was the most recent crew that had flown the space shuttle that was going to be ready on the launch pad. And so in order to pick the folks, you know, that were going to be the lowest impact and kind of dump us into a training flow associated with, you know, we're going to have a different payload on board, which was none if we were going to rescue a crew than we had when we went to the space station. But other than that, we had the same ship. And so they took the crew that had already worked together and had already flown that vehicle most recently and decided that that was the right people to get the shortest training flow and have them be best prepared to go and rescue the Hubble crew. And so we pretended like we were, of course, going to do it. We did simulators here at the Johnson Space Center with the right configuration, and it had a lot of power. That vehicle had a lot of thrust to get to orbit since it wasn't carrying a payload, so it performed a little bit differently, which was a neat thing to see because we didn't normally get to see trajectories that weren't going to space station with a whole bunch of cargo. We got to do something different from a training perspective, which was cool. I actually trained to do a solo spacewalk in case we needed to get some pieces of the space shuttle in the proper configuration, either to continue the mission or to come home. I trained to do a spacewalk by myself, which is not, you know, that's not what we want to do. We want to do something different, but we only had the hardware in order to do it that way. And it was only going to be in a kind of a deep contingency scenario, but I trained it and did the NBL runs, the neutral buoyancy laboratory training in the spacesuit, just like I was going to do it. I probably had more training to do that than I had to do this EVAs that I did this last summer on the International Space Station. That's how seriously we took the preparation for that mission. As far as mentally preparing for it, I think it really depends on the individuals. I think there are folks who would really struggle maybe with having a loved one or a spouse that you needed to go and rescue. But I think there are a lot of folks that, whether they scuba dive together or they rock climb together, or, you know, you can get yourself in situations where you need to operationally be able to work together to do the mission and not be so clouded by the emotions of what needs to happen next that you make bad decisions. So people do it, routinely, where their spouse's life depends on them doing a good job. So I think that if you take that mindset, it's something that it's definitely something you can manage, and if you have the right people involved. And luckily, I think my wife and I were folks who could manage that, and that was the decision that was eventually made. And so I appreciate you, and I know that she, if she could hear, would appreciate it as well. You referencing that she was the first or the last person to interact with the Hubble telescope, because some of the spacewalkers who put their gloved hands on it sometimes try to take credit for that. But since she put it safely back into orbit, I think that is the person who really interacted with it last, and at least the last person who could have made that mistake that would have been hard to get over in 2 seconds had they not done it exactly right.
Yeah, if you Zoom the next time with her, please say thanks to her from all of us. So I also follow your wife on Twitter, and I recommend everybody to do so. And she tweets a lot about science experiments she's conducting on the ISS right now. And if I know that correctly, you also had to conduct some experiments. And I was wondering, since you're not the scientist who designed these experiments and you're more a mechanical engineer by training, how do you do these science experiments that you're not directly an expert on? And do you get like coaching via video directly, or how does this work?
Much like I described earlier with the different payloads having different ways to interact, we have everything from, in some cases, a series of photos that say, make it look like this. In some cases where we have a video camera that we set up that's over the shoulder looking at our hands to make sure that we're doing the right thing, or that's monitoring the equipment with a series of cameras that are inside potentially, or even making measurements of different factors that may impact the experiment, and then getting coaching as to turn this dial in some way, or reset the optics to this, or the sample needs to slide slightly in this direction, or move the meniscus on this in this particular experiment to a slightly different location so they can get the pressure or whatever that they're looking for. And so it's all of the above. In some cases they understand the science really well and they can just say, make it look like the picture. But in other cases, we really do get that hands-on coaching to make sure that they get what they're looking for from the payload that has. In some cases, it's taken a decade to get to space station, and in other cases, we have launched experiments and tried to operate them really quickly, and those have their own challenges because all of the things that make it easier to operate in zero gravity and guarantee success aren't always included, and so they can sometimes be a handful to operate in space. And they're kind of with the mindset, if you get good data once, then we'll put the effort into making a 10-year run at getting a super high quality experiment put together so we can collect a whole bunch of data. But we want to get a quick look as to whether or not this technology or this technique is even feasible in zero gravity.
Thanks. Yeah, that's really interesting for us. So there's of course a lot of questions about the SpaceX flights, and I think I'm handing back to Andres for this.
Yes, thanks. Well, as we mentioned before, last year you went to the International Space Station with the Crew Dragon capsule from SpaceX. And we were wondering how closely are NASA astronauts and experts like you, who not only have been to space before, but also have a background in mechanical engineering, involved in the construction and development of the new spacecrafts from various private companies?
Andres, it's a good question as to what the right fit is. And when we put together the crews that worked on these first commercial crew vehicles, the Boeing Starliner that's hopefully going to launch by the end of this year, the SpaceX Dragon that I flew on, we did bring folks in who had experience developing new vehicles. I came from the F-22 program inside of the Air Force and mechanical engineering training, and as a physics undergraduate. And it's interesting whether it's the science or operating a vehicle in space. There's a little bit of relying on your engineering experience, but there's also some physics understanding that you have to kind of put into that whole kind of big picture of what's really going on. That's not something that's normal mechanical engineering stuff. It's interesting how that physics background kind of shades everything that how you operate, even as an engineer or a developer of hardware. And so primarily our responsibilities were associated with the interfaces that the crew was going to have with the vehicle and making sure that those were good. And so for the SpaceX vehicle and for the Boeing vehicle, and I hope for vehicles that are to come, like Orion or a lander for the moon or otherwise. We really have focused on trying to make sure that the crew has an operational way to interact with the vehicle and bring it home safely or bring themselves home safely, even if the mission is potentially kind of impacted. And so as we operated the Dragon vehicle and got it ready to go to space station, that's really what I focused on was, okay, always what was our path home if there was a problem with the communication system and the ground couldn't continue to help us get to space station, or how could we intervene to avoid impacting the space station? You folks that have been watching the human spaceflight for a long time might remember the Mir space station. There were some impacts of vehicles that were automated that hit that space station, that's not good. And with humans inside and humans inside our vehicle kind of across the board, we were always not necessarily looking to save the docking, but looking to avoid the bad day or have a path home or have a way to save the crew that the crew was in control of as the thing that we wanted from an interface perspective. And we really focused on those things. Of course, there are other things that you need to demonstrate that you can put your suits on and that they do the right thing. You can still operate them when they're pressurized for the minimal amount of things that you need to do. And so we tested all those crew interfaces. We did not jump in and redesign the heat shield or change the structure or decide how many computers were going to be on board with redundant software. What we decided was, those crew interfaces, and made sure that crews that have our training and experience could kind of operate them and get them home safely in a really bad day.
And this partnership with new private companies is actually with an eye towards the future, in the future of space exploration. And this will lead us into our next question. And Alex has some very interesting questions regarding this.
So we, of course, received a lot of questions about the future of spaceflight. And one big topic always that comes up is Mars, of course. So Rosa from Barcelona and Nicolas from Colombia want to know, so do you think a human mission to Mars is feasible in the 2030s, and which will be the hardest difficulties to overcome?
I think that if we were to decide and invest that it's feasible to do a mission in the 2030s, from a practical considerations perspective, unifying the governments or the funding streams in order to make that happen, I'm a little bit more pessimistic about in terms of bringing all those things together and being able to execute a mission. I think that, if we go back and we look at the Kennedy speech and, the decision to send somebody to the moon and then bring them back and having that be a national goal and allowing that focus to do whatever it took to accomplish it, it's the engineering is something that we could accomplish. But it's that challenge of being able to stick with our goal for a long period of time, and with the amount of resources that it's going to take to actually pull it off. And so from my perspective, I think it's possible. I think it's just really hard to predict, what the political will is going to be to kind of bring something together like that. As you may know, the International Space Station kind of on a recurring basis has to make decisions about how long the space station will continue to be populated and how long it will operate in low Earth orbit. And that takes an international kind of agreement, cooperation from our Russian colleagues, all of the member nations from ESA, from Canada, from the US, from Japan, that have come together to operate the International Space Station. They all have to be in agreement to kind of continue on. It'd be really hard for us to operate the space station without our Russian colleagues, because the thrusters that are used to change the altitude of the space station, we use them for maneuvering. We have some maneuvering capability on the US side, but we need cooperation, and that will, and predicting that you're going to have it for the better part of 2 decades, probably, to pull a mission like this off, is that's going to be the hard part. It's I think the engineering challenges are out there, but they're not insurmountable technologically. That's my perspective.
Yeah, I find this really interesting, because this was one of the questions, if it's more a question of money and work hours that we put into this problem, or more a real engineering hurdle that we have to solve. So from your point of view, it's really just a question of the will, the money, the work hours we're willing to throw at this problem.
I'm always amazed at the ingenuity when folks are challenged to solve problems, and I believe that they're problems that can be solved. And there could be something that you made a bad decision, and engineering wise, that we realized that the path we had taken was poor because we didn't pursue dual paths, to try to guarantee that one of those two paths would be successful by a deadline that, in terms of managing the orbital mechanics to get to Mars at the right time. We could face a challenge like that, but I think the engineering challenges are feasible, and there's enough ingenuity with the appropriate resources and organization that you could accomplish it. I'm dubious that we can get that organization accomplished and get enough people working in the same direction long enough to get it accomplished. That mother of necessity is invention is the mother of necessity. I think that's absolutely true. And if we had the mission, we could accomplish it if we were given the right resources.
It's interesting because Gustavo from Montreal has a question to that, and I think it fits really well here. So if we consider how fast artificial intelligence, robotics advance nowadays, does it really still make sense to actually send humans to Mars? What can a human do that a robot cannot do?
It's a great question, and it's an age-old question as to, we had the Voyager probes, robotic probes that have left the solar system at this point, provided a wonderful insight to this point. And I think that you really do need to understand the mission that you're going to give the crew is the mission one of colonization, to demonstrate that you can build a habitat on Mars and create some sort of sustainable system. Is that your mission? That might be some people's definition of the mission. And so very clearly the robots might not be able to do that on their own, because you haven't demonstrated if you didn't have humans as a part of that process. There are challenges that we do face that as a spacewalker, as somebody who's repaired things in space, both inside and outside. I will tell you that getting a robot to jump in and execute those complex repairs are challenging, but at the same time, repairing the Hubble Space Telescope, for example, I think would have not been feasible with a robotic mission, certainly in the time frame that we had it. And I think we would replace the Hubble telescope rather than repair it, with the robotic tools that are available even to us today. So I think that those challenges of how you adapt and overcome when things don't go exactly as planned are the humans help with that, and having them co-located can make a big difference. But I think that colonization piece is a big one, and I think that the unknown is a big one, and I think honestly a huge part of the mission of exploration includes having humans kind of accomplish some of that exploration. It's not enough to climb Mount Everest with a robot. People still strive to achieve that accomplishment, and I think that there's an aspect of that there as well. Now, in terms of deciding where you put your resources, I could see at times the smart money could be on a robotics mission, but there could be other aspects where a human mission is appropriate depending on what the objectives are.
Yeah, since you already mentioned the collaboration with Russia, I think Andres has a couple of questions on this topic.
Yes, so we have talked about the International Space Station, although it's actually only a few countries of the Earth who partner in it, and they're mostly from the global North. And what about other countries? For example, why should a country prioritize and fund a space program? For example, I am from Colombia in South America, where we don't have a space program, and I constantly think about how we might develop one, and why should people care about this?
It's a great question, and it kind of plays back to one that, whether it's the countries in the North that have a space program and continue to kind of operate one, and whether they should continue to invest in a space program. And from my perspective, it's the challenges of overcoming the accomplishment, the seeds of innovation and engineering that kind of go along with that, whether it's cameras that were miniaturized that have found a home in cell phones, for example, or radiation hardened electronics for use in other satellite applications. I think you can always find an example of something that was developed for the space program, the human space program, or satellite programs in general, that then has an application for something that was completely unexpected. And so for me, I think that part of that economy, if you will, of pushing the technological envelope, a great test bed for that is low Earth orbit or further out. And so if you want to be a technological powerhouse and you want to compete in that area, finding places that you can challenge your engineering industrial complex to be successful, I think whether that's undersea or in low Earth orbit or further out, those challenges help your engineering teams and industrial base be stronger, be better, and produce products that have spin-offs that are completely unexpected, but that are extremely helpful from a society perspective. So if you want to be a leader in technology, you got to challenge your technological forces, and space is one way to do that.
Yes, absolutely. And I can totally resonate with that as a scientist, as an astronomer, how pushing the boundaries of knowledge is going to push the boundaries of society and technology in particular. And Alex has a question related to privatization of space that we have talked about recently.
Yeah, I mean, we have to, all these questions came in, of course, since you've used a SpaceX rocket to fly to the ISS. And especially as astronomers struggle a little bit with the amount of satellites that have been put up in the recent time, which cloud our vision from the Earth a little bit. But of course, there's all this problem with more and more space trash becoming dangerous for human flight. So do you think now that private companies start to reach the space, do we need more regulations of space, what we can do, what is allowed in space?
You know, I think that it's a balance, right? We need to figure out a way to put the appropriate regulations in low Earth orbit or further out so that we don't destroy the environment that folks are taking advantage of, right? And this is true in many places. You can, whether it's mining for resources on the ground or undersea, we need the appropriate regulations to prevent the pollution of the very resource that people are trying to take advantage of. And so I think it's a real challenge, whether it's light pollution or as the more satellites that go up, it's always the case that the more satellites that go up, the more satellites that are in orbit that are failed, that are slowly migrating back to Earth and can be a problem as they come back. And so we need to manage that pollution with the appropriate regulation or the appropriate technology to manage it. And in terms of what the right answer is, I don't have it, but we definitely need to have folks think about it. And the proliferation, if you will, of commercial entities in space is really sets us up. We've managed to do it for the electromagnetic spectrum, for example, because there can be challenges with people with their ham radios in their backyard impacting cell phone signals or a wide range of television signals or otherwise, and that process has evolved and been managed, and we'll need to do the same sort of things. And I know we are, but it's going to continue to be challenged as more folks participate in space. But we got to protect and not pollute the very resource that folks are trying to take advantage of or use.
And along those lines, do you at NASA, for example, think about ethical considerations for space exploration, for example, extraction of resources, or you mentioned colonization? What are your thoughts on that?
I think across the board, and I can't speak for NASA, but I think across the board, those ethical considerations are always something that as a scientist or as an engineer or faced with an opportunity just in your daily life, you need to wrestle with and consider somewhat. And so, there are personal decisions of where is the right recycling, how much resources do you put into recycling something versus discarding it and moving on. And that's an ethical decision as we go and we interact with whether it's another celestial body or even the space environment that's around our planet. There's an ethical decision as to, hey, do you have the right to occupy and disturb and pollute because you can get here? And I don't think that just because you can get here, you have that right. As a me as an individual. And I think that we should have a long and hard discussion, and it plays into the regulatory question that maybe Alex was asking earlier. I think those are important decisions, and I think that just because you can do it doesn't mean it's the right thing to do ethically, right? And I know scientists have a long history of having to wrestle with this, whether it's folks who develop the technology for nuclear weapons, for example. Is it something that you should do because you can, and then when it gets unleashed, have you done the wrong thing? And so I've always kind of thought back to Star Trek and the Prime Directive and things like that as it's more complicated than just the Prime Directive in many cases, but it is, that ethical question is one that it definitely needs to be considered.
Yes, absolutely. And these things always go hand in hand, and they're very important, as science doesn't happen in a vacuum. And I think we're running out of time. But Alex has one last question that I'm very interested to hear.
I was going to say that question with the philosophy and throwing in a Prime Directive answer was a great one to wrap up a bar talk. But I appreciate one more. I was looking at the clock as well and thinking, hey, that'd be a great, we get to philosophy at the end in a bar talk.
Yeah, we only wanted to know, we know that you answer the same questions 100 times already. You are participant in many of these events. Is there any topic you wish you could talk more often at these events? What should future organizers ask you that you can finally talk about?
I think that one thing that we didn't talk much about, and I talk about it in some of the other presentations or events that where it comes up, is it's really about, and it's interesting how kind of scientists and engineering folks tend to not go in this direction, but there's a human element, kind of an emotional experience associated with flying in space, preparing your family to fly in space, and how you best prepare yourself to perform at your best emotionally over the long duration that you might be in low Earth orbit. And as you folks talk about going on to Mars, kind of the challenges of keeping the crew motivated and performing at their best there are many technical aspects to that. They need food, they need water, they need no carbon dioxide if that's what you can give them, but they need other things as well, and we'll need to consider those things. And it's worth, I'm a scientist and engineer, and that's not necessarily the thing that I would put first on the list of things that I think need to be accomplished. But I do, having lived in on the space station for months, recognize that you can make a big difference in how well folks perform by how carefully you consider some of those softer aspects, if you will, of how you take care of humans when they're in space or on long duration missions.
And on that note, I completely agree that we can finish with the human aspect and the ethical aspect, like as if we actually were in a bar. So I would like to thank everybody for watching, and thank you again, Dr. Behnken, NASA astronaut Bob Behnken, and hopefully next time we can meet in person in St. Louis.
Thank you, Alex, and thank you, Andreas. I very much appreciate the time to talk to you and your folks, and look forward to having a little bit more of a human interaction the next time that we meet.
Thank you.